So in this video, I'll be working with you on or showing you how to analyze the end behavior of a function, or generally how to analyze the features of a polynomial. And the first part of this video, we're going to focus on end behavior algebraically, how to write it algebraically. Okay. So generally, the idea is that if you are given any function, any polynomial function, you can actually classify into four possible ways, four possible shapes. So if it's an even function, you will have something like this on the left side over here, either that both sides are going up forever or both sides are going down forever. So, or if it's odd, one side is going up forever and the other side is going down forever. The correct way to say that would be one side is increasing forever, the other one is decreasing forever. At the same tier, one side is decreasing forever and the other one is increasing forever. So we're going to clarify the language as we go through this. The first thing that I want to show you is to use this example right here to clarify those languages. Okay, so we're given a polynomial. Sometimes you need to rearrange the polynomial in the standard form. This is obviously not in the standard form because you can see that the degree is going from low to high. It's supposed to go from high to low. So this is the highest degree. It doesn't usually follow that it's the last one. Sometimes it's not in order. It might be in the middle. So you have to look for the highest degree, which could be anywhere in any of the terms. Okay, just rearrange them. I'm not going to rewrite everything. I'm just going to write the first term that has the highest degree. All right, that's the first term, and then it has the other one that goes and in the front of it or the back of it. Okay, so now using this leading term, I can classify this into one of those graphs I show you up here. So either it's going to be even or odd. Okay, let's start with the exponent, the degree. So you can see here the degree is 5. It's a 50 degree polynomial. So that is odd. So I'm going to write odd here. This is odd. So I'm going to be looking at this right side. I'm looking at this right side because it's odd. And then I look at the number in the front of the x called the coefficient. This coefficient is a -8. Yeah, so it's a negative. So it has a negative leading coefficient. So it's negative leading coefficient, negative. All right, so that gives me the information of I'm looking at the right side, but I'm going to be looking up or down. Because it's negative, I'm going to be looking down here. So that means my hand behavior will be like the one I'm circling in yellow. All right, so the end behavior will be this I shaded in yellow, highlighted in yellow. Okay, so that's how you analyze them. All right, so now we're going to write it technically the way it's supposed to be written. All right, so we can see that as x is going to the right, so let me draw a bigger one here. As x is increasing, so if this is the case, so this is right side is going down. So as you are going fast, adding more x value, you increasing x value, the y is going down, the y value is decreasing. So this is going to negative infinity as x is going to infinity. This is x going to infinity. This is y going to negative infinity, approaching negative infinity on the right side. The same way, if you look at the other side, I'm going to draw it in another color, the left side. This is the left side like that. So as I'm going toward negative infinity, as s goes towards negative infinity, you're going to the left, y is going toward positive infinity, positive infinity. Usually we don't write a positive infinity. So now I'm going to write it down as it is written in delta math for you. So we're going to say as x is approaching positive infinity, f of x is approaching negative infinity. That's for this side, the right side over here. Okay, that's for this right side I'm circling over there. All right, then the left side will be as x approaches negative infinity, that's the left side. All right, I'm going to circle in green. This is left side, I'm circling in green. F of x is approaching positive infinity. Okay, this is the answer that you're going to pick, and this assignment there is a multiple choice, and that's how you analyze it. So if we were given something, if on the other hand, if this one I'm highlighting in blue was the leading coefficient, that would have been even, okay, and then you would have written the a little opposite from here, because you even and positive, that means you'll be selecting from here, okay, and then you'll be describing it as s goes to infinity. Okay, let me write it for positive and even. So let's scroll up a little bit so you can have an idea what's happening if it's positive or infinity. So let's say you decide it's even and positive. It's going to look like this. So as x, okay, as you're going to the right, as x going towards infinity, then y, f of x, is approaching also infinity because it's going up, they are positive. But as you're going to the left, let's say you're going to the left over here, x approaching negative infinity, then y will be approaching, or f of x rather, f of x will be approaching, so f of x will be approaching also infinity. Positive, they're both positive. They'll be both positive. On the other hand, if you are given one that is positive, this one is positive, leading, and then it's also even degree. All right, let's say you are given the other one. If you're given the other one that's a negative leading coefficient and even degree, so as x is going to infinity, you can see f of x will be going down to negative infinity, and s is going toward negative infinity, and then f of x will be going toward negative infinity as well. Okay, so the same idea you can use to analyze the other ones. Okay, that's easy enough. The next one, level 2, this is level 2 of the feature. It asks you to determine several information based on the graph. Okay, so the first information is to determine the degree. All right, so you see this graph over here is facing up. It looks just like this. It looks like this one on the left. It looks, let me put a letter on them. So it will be A, B, C, and D. Okay, I'm going to refer to them as A, B, C, and D. So this graph, both branches are pointing up. It looks just like A. It looks like that. It looks like the quadratic. I'll draw a little one by the side here so you can see what's going on, okay? So that's going to help you determine what to put over here. The degree will be even. So degree is even. All right. And because it's pointing up, the leading coefficient will be positive. Positive. All right. And now, this is a part that we didn't talk a whole lot about in class. Actually, we talk about the zeros. So the zeros are these places. The zeros is where it's crossing. It's crossing over there. All right, that's crossing. But it's crossing dancing. That means there's a multiplicity of 3 right there. And then there's another 0 here of a multiplicity of 1. And that 0 here of a multiplicity of 2. There are only 3 zeros. So there'll be 3 zeros. All right, because those are the only places it's crossing the x-axis. So the zeros are the point of intersection. They're right here. Zeros are the x-intercepts. Just count them. Okay, so there's 3 of them. 1, 2, 3. Although the multiplicity are different, so it doesn't matter. Just how many places is it crossing? 3 or touching. Okay. Now the last one is talking about relative minimum, relative maximum. Or in another example, we'll talk about what is the extreme value. So let's talk about relative minimum, relative maximum first. Okay, so if a graph is doing this, let me draw a general one here. Let's say graph doing this, okay. All right, when it's increasing, and then gets to the maximum possible locally, so that will be a relative maximum. This is a relative maximum value, maximum point. All right, and then if it's decreasing and gets to a minimum before it starts rising again, this will be a relative minimum. Then we can say this graph has, this one I just drew here, has two extreme values. So if you, in the next example is going to say what are the extreme values, relative extreme values. Okay, this one has two extreme values. So this one has two relative extreme values. So right over here, two relative extreme values. Okay, I'll draw another one that's different from that, and then we'll go to the problem. Okay, here's another one. Like maybe it goes like this, like that. Okay, so it has point. This point here will be relative maximum, relative minimum, relative maximum, relative minimum, relative maximum. So it has three peaks. Those are relative maximum, and then it has two troughs. Those are relative minimum. Altogether, there are five extreme values. Okay, three of them are maximum, max, and two of them are minimum, min. I hope this helps because we didn't get a chance to talk a whole lot about this in class, but it's okay now. I hope you get it. It's not hard. So we go back over here and our count. We're going to count minimum, okay? There's a minimum right here because it's going down. That's a minimum point. I want to highlight that place. This is a minimum point right here, highlighted in blue. And then the function increases, and then it gets to a maximum over there. But we're not looking for maximum, so let's kind of blow it up a little bit. We're looking for minimum. So here will be one minimum. This is one, and then this is going to be another minimum. That's two of them. So minimum occurs at the point where the graph reaches its low value and starts increasing again. So this is a minimum point. That's a maximum point. We're not counting that. We're looking for another minimum point. So it's two minimum, relative minimum points. Okay. This point over here, it's not minimum, maximum. It's a point of inflection. We're not dealing with that right now. So this one right here is neither minimum nor maximum. It's a point of inflection. So we don't deal with that in Algebra 2 yet. So you're going to deal with that in calculus or pre-calculus. All right, anyway, so that's a relative minimum. Is going to be two of them. It's going to be two of them. So for this part, you are just counting the troughs or the peaks, okay? Let's see another example of that. Here's another example of that. So based on the information I gave you before, we can analyze this. Let's analyze it, okay? So we have this one side, the right side is going down. So it looks like this. It looks like this, that the cubic function with one side going on. So it's going to be odd. So they are odd. One side is pointing down, the other one is pointing up. This is odd. This is an odd function. So the degree, and then we can do the degree. Let's do, what degree it is. Okay, let's see how we do degree. All right, let's count all these places and their multiplicity. So we can look over here. There is 1. Okay, that's 1. And actually, we're not looking for the zeros or the multiplicity, so we're just going to know that the degree is odd. That's all. I was trying to make it too hard. This is odd degree, because it looks like the cubic function is similar to it. Okay, it's odd degree. And the leading coefficient, all right, so this is like a reflection. So it's odd. It's negative. Sorry, it's late in the night. This is negative. We know it's negative because the right side is pointing down. Right side, right down. So that's a negative. Now, let's see how many zeros are there. Remember, I told you from the previous example, the zeros are those intersections. 1, 2, 3, 4, 5. Okay, those are the 5. And, you know, the multiplicities are just 1. Multiplicity of 1, because it's not bouncing and it's not dancing. So it's 1, 2, 3, 4, 5. So there are 5 zeros. So that's 5 real zeros. And then extreme values. So remember, I showed you extreme values over here at this example right here. Okay, these are extreme values are the peaks. You count how many peaks and how many troughs. Okay, let's count how many peaks and how many troughs are here. Expand it a little bit. All right, this is I'm going to highlight them. This place is an extreme value. That's 1. This another extreme value, that's 2. Another extreme value, that's 3. Another extreme value, that's 4. It has 4. 2 of them, these 2, let me shade them in blue. These 2 are relative maxima, and these other 2 in yellow will be relative minima. Okay, so this will be relative minima. Okay, and then so we have 4 altogether. There are 4 extreme values altogether. All right. I think there's one more example here. Yeah, there's one example here that we need. I can just do this quickly. All right, so we have this function given to us. We know that it's odd because right side is up, left side is down. So this is odd. And then we know that as x goes to infinity, as you are increasing there, the y is going up there. So that means as s goes towards infinity, f of x is going towards infinity as well. So we can eliminate some of this answer quickly. So look at the right side. It cannot be this one because it says it's going down. It could be this one because it says it's going up. It cannot be this one. So it could be A, it could be B or C. So it cannot be this, it cannot be this. All right, now let's look at the left side. As x is going to negative infinity, f of x is going down. So as x is going toward negative infinity, f of x is going towards negative infinity as well. So we know it cannot be the first one or the last one. Let's look at these two. As x is going towards negative infinity, y is going towards negative infinity, which matches this graph over here. The other one says going up. That's not correct. So it cannot be C. So the answer has to be B. So this is the answer to it. As s is going to the left, negative infinity, y is going down. As x is going to the right, y is going up. And that is the answer to that. Okay? I think that was the last example I pulled from Delta Math. Hopefully this should help you to answer all the questions and do everything that you need to do. All right, so remember to get high on math, not on math.